Morning, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 90 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Swamy, our speaker for today's session. He is an aspirant software architect and currently works at Applied Information Sciences. He loves to learn about new technologies, but for now, I will hand over to Swamy to begin the session. Over to you, Swamy.
Hey, thanks, Rashmita. And let me share my screen and please do let me know if you're able to see my screen. Is my screen visible?
Yes.
Oh, okay, thanks. Let me drag these. Three. Okay, that I'll do once we start. Hey guys, thank you so much for joining this morning. We will have uh, a lot of discussion on scaling. So let me start this. And let me paste the URL where you will get the source code. This is my GitHub repository, and it will be under this speaker series. All the sessions, whatever we are doing it, the demo script as well as this source code, everything will be available there. Okay, so you guys can go grab it whenever you want to do a hands-on. Okay, that's here under the Microsoft Reactor, the session 9 and session 10. The previous episodes code you will see in speaker series hyphen 2021. Now this year 2022, you will see all this sessions, demo script as well as the starter files. And I did a very small benchmarking source code. It's a very small ugly code, but still I have saved it here. We'll be using this benchmark tool also shortly. Okay, coming back to our session, what are we going to do today in next 90 minutes? We will be doing work in and around the Azure app service scaling. Okay, what it is, how do we do that, and how do we recognize that our application has been scaled, and everything will learn around that. Okay. So I'm still a learner. Apologize if I do any mistake. And that being said, we will first look into how and what this scale up and scale out is, and we'll do first scale up. Let's do a scale up first, and then what we will do is we'll do a scale out. And then how do you do the scale in, scale out manually? How do you do the scale in, scale out based on the schedule, based on a specific dates and auto scale? Sorry, auto scale is the one which needs some of the load to be pumped in. So we'll artificially pump in the load using this benchmark, this one, as well as I will execute some of the script from Postman. Okay, we'll do these things to pump in the artificial load. And our main focus will be this live metrics. At this point of time, there is no traffic coming in, but eventually we are going to start pumping in. And that being said, this is my Azure virtual machine in Azure where I installed all the software. So, we'll use some of the applications to pump it. Okay, first let's see what all these applications. One is Web API. It's a simple Web API where we have products controller. That's default. It brings hard-coded products, and one is the professors controller, which brings in all the professors. So the database is the same database which we used to use. This is the Azure Data Studio, folks. It's very nice tool which I love always. So I can get into that a new script, a new query window here, and I do select star from professor. Okay, we see couple of rows are coming. Nothing, and it's just a plain simple database. Okay, and one thing to observe here is I am able to access from this virtual machine the SQL server. But if I go and check this, this virtual machine doesn't have any public IP. So we didn't punch hole in the firewall for that. So if you see that, this is uh, my home's IP address. What is my IP address? If I go to what is my IP address, you can see that it will give it is 150.19. So let's check that 150.19. So I will be able to access this database and couple of IPs which I unblocked it here, whitelisted here, those IPs. I'm sorry, I'm having some running nose. So those IPs, these two IPs are of those web APIs. We'll see that. And how am I able to access this from the virtual machine? So what I did is I did the VNet integration. So I clicked on add virtual network, and wherever this my virtual machine is there, that virtual network I have added it here. Just I wanted to show you real quick that integration piece is very important, and you guys can use it if you're exposing some of the SQL Server through this VNet integration. So here, if you can see this, this is my resource group, and I have two of my virtual machines. One is this Ubuntu, and one is Windows 10. So just have all the tools on .NET. So some of the experiments or sessions we'll do it from Ubuntu VM, but today's focus will be purely on Windows VM. So this is here, and if you go, you see this is a virtual network. In this virtual network, I have these virtual machines placed, and one is for the Bastion. So I didn't expose any public IP for these VMs. So if I go and see this Windows 10, I don't have the public IP or DNS. It's all the private IP. All I connect through the VNet, uh, the Azure Bastion. Azure Bastion will help me get connected to these. So the important thing is when we enable this VNet, what will happen is it will create a service endpoint. So using that service endpoint, your virtual machine, whatever the virtual machine which is there, that will be able to connect to the SQL server. So when you do this integration, just a tip, guys, when you enable this virtual network and you have some virtual machines inside that, something you want to access it, so you have to come and enable it. We can add other service endpoints. You can check here. Active Directory, Cosmos DB, Cognitive Service, Container Registry, Event Hub, Key Vault, Service Bus. Now you understand how the virtual machines will be able to access the Key Vault to get some credentials. So SQL, storage, and web. That's just a tip. How are we accessing this one? Okay. Now coming to the main point. What is the scale up and scale out? Okay. I'm sorry, I'm having some running nose. Okay, there are a couple of terminologies. Different people will use different terminologies. Some people will call it as a vertical scaling versus horizontal scaling. So you can see that vertical, something it's growing vertically, something which is growing horizontally. So similarly, scale up, so something which is going up, and scale out, something which is going horizontally. So what does the scale up means? So let's assume we have an on-premise server at our office, and that used to cater the needs of our bookstore or a bookstore or food order app, and it used to have 200 users throughout the day. All of a sudden, the load started increasing, and 500 people are logging in, and our application is either being slow or sometimes it throws an exception. So what options do we have? One of the option what we can try is we can increase the load fan. We can increase the capacity of the we can increase the capacity of the hardware whatever we have, and the way we write the code will also impact the performance of the application. If you write an ugly code and you have an excellent hardware, but still our application will be having lot of latency. So at least in a positive scenario where the code has been written excellent, but we are running short of either the CPU or memory or a disk activity, something which is little less. So in that case, what we can do is we can do a scale up. So what does this scale up is when you want to increase the capacity, and scale out is what some of the people what they do is okay in on-premise scenario, whatever in on-premise scenario we were talking. So in that case, we found that we are running short of memory. So we already have 32 GB RAM and we want to buy another 32 GB RAM, and we placed it, and for 1 month we had 500 users, and after 1 month what is happening is the users has come down to 200, the normal. Maybe that was a marriage season or whatever it is, people started ordering food from our application. Now after 1 month the traffic has come down to normal. Now what do we do with this 32 GB RAM? We have to keep it there or we have to throw it. There's no resale value. So when we come to this cloud provider, Azure or any cloud provider, what will happen is you can scale up for this 1 month, and the moment you observe the traffic is coming back, you can scale it down. So it's no extra charges or no commitment. So whatever the uh, extra hardware resources you use, it you will be charged only for that. We don't need to spend uh, we don't need to spend anything more than that. So that's one good advantage of that. Okay, so let's discuss about the scale out and then we'll go purely hands on. So this scale out is what um, let's come back to the purely cloud scenarios. So the strategy what different architects they suggest is to have a smaller capacity of the virtual machine and scale it and scale down as and when it is needed. That means instead of high selecting, and again that depends upon the kind of project, the kind of load you get it. So what I'm giving you one of the scenario, it's not the universal formula but one of the scenario. Let's assume that and the criticality of the project is also very important. Let's assume if it is a financial project or if it is a medical project where it is very critical. Now the medicine doses or whatever it is, if that gets delayed, then it will be huge risk. So based on that we have to choose the size of the virtual machine or the size of Azure compute unit. For this app service, the size of the Azure compute unit is very critical. So coming back to this one, one of the strategies is to take a small like uh, S1 SKU for this app and auto scale it. So what will happen is if at all we are working in Indian time zone, let's take this example. So there is a normal traffic from morning 9 a.m. to evening 8 o'clock. And after 10 o'clock or 10 p.m., maybe rest of the world is also trying to hit the same application, and the load has been multiplied by number 3 or 4. So instead of getting 250 requests per hour, we are getting 1000 plus requests per hour. The scale has been literally more than 300%. So how do we handle now? Operations guys will be um, will be gone, and we will not be able to scale it up. So what we will do is we will scale it auto scale. We'll put it on an auto scale based on some metric, maybe the number of requests which you're getting, or the CPU or a memory. We have a scale, uh, scaling up, scaling out, as well as scaling in. That means horizontal scaling. Okay, expand and shrink, just to be in that terms. And also there is some isolated tiers where we will be having a maximum of 100 instances. So in the standard instances, it is 10. And if you go to premium, there will be another set of auto scaling. So just to summarize, to scale vertically or scale up, we will increase the hardware capacity. And horizontal scaling or scale out means we'll be adding more number of instances. Okay. And how do you want to scale out or horizontal scale? So do you want to run on a specific dates? That means today from 4 p.m. to 6 p.m. There's a deal which we are published. So we are expecting a lot of traffic. So we want 3 instances of our application, or on Thursday and Friday, there is a lot of traffic in our application. So we can say the specific dates, keep 4 instances. And on Monday, Tuesday, Wednesday, it is some less number of instances. Over weekend, it is only 2 instances or 1 instances. So different uh, scaling things based on the dates. Okay. We will identify the trend, and based on that we can do it. And another thing to note here is, even though we do a proper research, sometimes there might be traffic which we wouldn't have predicted. So in that case, the auto scaling will be the best approach. Okay. So that being said, we'll start with the uh, with this auto scaling thing. So first of all, let's see the scale up. So even though I marked it as S1, this one, I am using a different uh, app service. So let's first go to that app service. Here, app service S1. So in this app service, if you see, I have 2 applications in this. So every app service, I am deploying an API and a application. Okay, just to see what they are. We'll come back to that one in a minute. But these two are there. And coming back to this one, I have taken this as a B1. Okay, I have taken this as a B1, and you can see that a minimum memory range uh, it is around 60%, somewhere around 55 to 60%. That's it is moving in. So you can see the CPU percentage, but the memory consumption is little high. Now the first thing is, how do you scale up, and what are the rules you need to understand, right? So if I want to take free, what all the facilities I get and what compute units I'm getting. So the compute units I'm getting 1 GB RAM and 1 GB storage disk. And I can host the application which will work for 60 minutes throughout the day. If the consumption is anything more than 60 minutes, then this is gone. And the next thing is the shade. If at all I take this shade, in that shade, what will happen is the consumption, the compute units is again 1 GB, 1 GB, but I'm going to get 240 minutes a day of compute, and I will be able to have the custom domains. So instead of bookstore.azurewebsite.net, I can say that manishbookstore.com, something like that. Okay, I can add it. So when I go to basic, what is that I'm getting? I'm getting custom domains, as well as I can add my own SSL certificate to that. And I can manually scale to 3 instances, right? And I will get this a dedicated Azure compute unit and so memory and this much of storage disk. And one more point to note here. Um, One more point to note here is, if at all we select any of the, if at all we select any of the Linux version of app service. In that case, we will not be able to get the shared tier. It will be only free and basic. Let's see that real quick. So we'll go here. I'll drop it in that scaling, and I'll call it as the oh, what happened? Bookstore Ubuntu, and I say that the stack is .NET 6, and I want to go ahead with the Linux one, and I will drop it in East US, and I'll come and create the plan. Okay, naming convention. I think I have given that site multiple times, but still plan. I'm calling it as a plan, and let me come and change it here. You see this? In the dev test workloads, it is either free or basic. But whereas in Windows, you will have free, you will have shared, you will have basic. And each one will come up with set of services and price. You're going to pay price for whatever the services which you're using. So in this shade, it's only 600 rupees, but you only have the custom domain. You don't have SSL, adding your own SSL. I'm sorry. So here in this basic, you have domain, custom domains, SSL. You can do a manual scaling up to 3 instances and other facilities you are getting. Now it is charging around 4,000 rupees. Now coming to production, you can see that there it is manual scale. Here you can do a auto scale of 10 instances, and also you have a staging slots, 10 times backup. You have a traffic manager, and you see the dedicated Azure compute units. And now if I go to P1, so what I'm getting P1, here it is auto scale of 10 instances. Now here if I go to P1 V2, it is 20 instances and 20 slots. And here it is just a 5 slots, right? And let's go premium V2. It's something should be different. It's 50 times backup. In this one, 20 slots, 50 times 20 instances. Okay, maybe the compute units is different because literally it is 10,000 rupees and here it is 21. So almost double the price. So that means they are giving an compute unit. See, it says that 7, here it is 3.5 GB RAM. Here it is 7 GB RAM. Here it is 210 Azure compute units. Literally it is 420 compute units. Double the Azure compute units, right? So you're getting a lot of facilities. So what is the, okay, it's in memory. So literally it is double. So as and when you see this is again double. It's 7 GB RAM. Here it is 14 GB RAM. Here it is 240 Azure compute units. It is 840 Azure compute units. Now all the way you can go to this premium tiers. And here it is 30 instances. You can scale to 30, and let's give it a minute. So in the V2 series, we see this 20 instances, and in standard it is 10, and P1 V2 series, that's 20 all the way. Even if take P3 V2 series, it is 20 instances. And when I come to V3, it is 30 instances. So net what is that is you're getting compute units as well as a lot of facilities, and you have to pay the price for that. I mean, what kind of facilities do you need? Based on that, you will bump it up. And if you come in here, isolated tier. So again, this isolated tier is more, as we have seen that you can go all the way till 100 units, right? So where were we? Okay, so in our this thing is 100 Azure compute units. It was in B1. So now I go and I am choosing to come to S1 standard. Once again, let's see that. I'll come to this service plan. Inside this app service plan, our memory range is this. I will come and verify that there are two apps which are running in this. Now go to scale up and I select standard and I select this and I click on apply. It takes less than a minute for this to scale. Then we'll see how the things are changing. So I can come back over here and you can see this is S1 standard. Now I can come back to scale out. We'll see. We'll come back and we'll look into this a little later. Now I can do all the way scaling up to 10. We will come back to that. We'll not do anything now. So that's the first section we have discussed. The scale up or vertical scaling, where you're adding more compute power. We have seen that. So we were there on the basic and then we moved to standard tier. So here it is only 100 compute units, total 100 compute units, but the series, that is A series equivalents, virtual A series virtual machines equivalent compute power, we are getting it for the standard, right? So that's what I mean. It's not exactly the A series virtual machine, but he's telling that A series computes equivalent power you're getting it to execute this. We have to pay 5,000 charge for that. So that's the first experiment. Now the next thing is we'll see how the memory and the things will get impacted, or how can we identify any issues and other things. But let's come back and learn. I have one shared app service plan. Let me come back over here. So let me go to this shared app service plan. Inside this shared app service plan, I have two apps, right? So one is, let me go to that. That is this API. And let me go to that bookstore. That's shared and bookstore is shared. Right? So this is the one API and this is the bookstore. I can click on this bookstore if you want to see. It's just a simple hello world of e-commerce solution which I started building in. Eventually, we will see that this will be fully built in few months with microservices. I just started with this. It's an in-memory database, so we can come in here. It's a simple application. We go and we'll come back. It's just a simple hello world. And from the API perspective, for the shared, here is that API. I can go and get this content. And one thing to observe that when I did the first time hit, it took a lot of time. That this one, see that it took a lot of time to get this. It took 12 seconds, which is unacceptable. And why it took 12 seconds and why it is taking 296 milliseconds, which is way more than. So the thing here is, if you come back to the shared and go to the configuration, if you come there and go to this configuration, I don't know whether that will be available, but if not, wherever it is available, I will show you there. So something known as always on. So right now this guy is not allowing because the lesser skew is not allowing. When we go to the higher skew, we'll come and see that. Prevents your app from being idle out due to inactivity. So because the shade, I tested everything before coming to the demo. So at that time it was active. Now after a few hours, this will go to idle state. So that's the reason when you do have first hit, it takes a lot of time. It has to warm up all the infrastructure or load it and pass through all the DLLs, load it in memory, whatever it takes to bring this application from cold mode to warm mode. So that's one tip, folks. Okay, so based on this, you want to enable this always on. If you see a sudden spike of users, they're coming around 6 o'clock once they come back home and they want to buy food. So you have to keep this application warm so that people 12 seconds people can't wait to order the food for any application. 12 seconds they will go and they'll buy it from somewhere or they will go and cook. So just to have these benefits we have to do. Okay, the jokes being apart, we if we come to this shared tier, if we come to the shared tier, we will not be able to do anything from the auto scaling perspective. So we will not be able to do anything from auto scaling perspective. So just to see that how the load will impact us, let's do some of the experiment in each of those tiers. So now that we have, I might get faced with some issues, but I know how to fix that if at all we are facing some problems. Okay, we are here. There was a bump in 50%, and then again it has come back. That should be fine. So I will execute a small script. I can do that in multiple ways. One thing what I can do is I can come to this postman and okay, let me uh, basic. That's This for the basic one. All the basic one, I'll move it to this one so that we can send only the load which is read needed for shade. So inside there, click on this collection and click on run. And that's one way to increase the load. Let's execute it 1,000 times with a gap of delay of 1 millisecond. So we started pumping in the load and we can come back to the application insights and you can see this live metrics. It started pumping in. So there are 2 requests per second. It is coming right now. Now, if I want to bump it up, all I can do is I can come in here again, do a rerun of this. I will say that pump in another 10,000 load with 0 milliseconds gap. Now this is like a dangerous thing. Just to understand, now see that it's almost doubling the number of requests. So initially it was 2 requests per second. Now it is coming around 4 requests per second. And you can see that there was a bump in request duration. All the way it was around 200 mil. Now it is past 500 milliseconds. It's almost touching 600, but it didn't. So also you can see that outgoing calls or the dependency calls, because it is going an entity framework core, we are hitting the database. So you can see that committed this thing and everything is coming in here. So, and also we can come and see the here it will show the memory. Yeah, there's a one. It will show the memory, how much memory it is consuming. It will show this graph here. Maybe it will take some time, but it will definitely show, guys. So other way to find out is we can come into the process explorer over here. Once we come to the process explorer, it will show here. Let's go to that bookstore also. I will come to this process explorer. You can see this, the process explorer, and this is the instance ID, and that you can see the instance ID is here. 22A7. 22A7, that's an instance ID, and that is being executed from this computer. So this is the computer and this is the instance where it is executing. So you can see that what is the memory, but it doesn't help much, but at least you'll be able to see something here. The other way to get this up and running is we will see to do a full refresh, and similarly you can see both the processes here in the process explorer, and the application insights will give a good picture. So always it's coming around 4 requests per second. Sometimes it is bumping up. And just to put load on top of that, what we will do is that's the shared one. I will do that. Actually, I should have configured in the app config. I didn't get a time. So I did this crude coding. Sorry for that. Okay. Now I'm executing this benchmark.net. This is also there in the coding, which I did back in 2021 when I was doing a gRPC session. I did a benchmark to find out how does gRPC versus API. So I use the tool and I am pumping in the load. This benchmark, it goes and it finds out like how much load we are pumping in, what is the lowest, highest milliseconds it is taking, and it gives a lot of mean, median, standard deviation, whatnot. It does. It's a good tool to find out. So now we are pumping in the load from 3 different places. You can see that it crossed. Now initially when we had load from one postman, it was 2 requests per second. Now it is 4. Now it is 6. And I want to go crazy. We can come back over here, right mouse click on this and debug, start a new instance and come back to this one and let's bump it up the load. Chalo, 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 start. Ah, okay, here you go. So it started. Oh, someone would have already done the 1,000. Okay, we are pumping in load from 4 different places. Like we are simulating this one. So now see that the number of requests it is past 6, almost it is touching 10. That means it is 8. It's due to my laptop capacity or whatever it is taking low. Or if not, you can see a sudden spike in majority of the calls which were under 200 milliseconds. Now it is going 400 milliseconds. Like we will do a proper analysis like what is taking how much time, and also we can see that reflection over here. You can see that it was almost 0, and now suddenly it started bumping in the percentage of CPU usage over here, and we can check that. Okay, so that's how we have to observe that before we go ahead and do some kind of scaling. We have to have a proper monitoring tools to find out like how many requests are coming, how within how many milliseconds we are able to send the response, and are we piling up this one. So what was the instance name where we were executing this one? It was webwk. So you can see that webwk, either of this is that. I think see this, it is showing the number of seconds here also. So you can come and find out all these things. Okay, so I will ignore that. And the other important thing to note is we have to keep a watch on the application map also, so that we will know all the integration points. Now see that this is one of the instance. This is an API. This is a bookstore. It doesn't hit anyone, but this guy is hitting the SQL server. There were already 311 calls. Okay. So that being said, let's go to the step 2 of our journey. Let me come back to this. So let's come back to the shared one. The basic. This is the shared. Yeah, basic plan. Shared one. We just saw that. So let me stop all these things so that we can again pump in the load to see some differences. I'll stop. I'll stop this and I'll come back here and go and check the live metrics. The traffic would have been reduced by this time. Okay, I think some of that processes is still getting processed. Never mind, that will not impact us. Okay, so that being said, let me close this. And let's come back to this one. This is a basic plan. And one thing to observe here is it says B1 colon 2. Let's go back here. Uh, let's go back to the resource group. And when I go to shared, it is D1 shared. It says that. It didn't tell anything more than that. Now, if I come into basic, it says basic 2. That means I have manually scaled it to 2 instances. I have manually scaled to 2 instances. So let's come back. I'll open one web API of the basic here. And again, I'll go back to this and open basic bookstore app. So that means what will happen is the traffic will get distributed between 2 instances. Wow, that's a good news. But 2 instances means if you're paying 2000 rupees per instance, when you bump it up to 2 instances, technically you're paying 4000 rupees, even though the SKU is charging X number of amount, multiply by number of instances you're running. So whatever the SKU, it says that 2400 rupees for one instance. Like we saw that it was 2400 rupees of basic. It is for one instance. Now I'm running 2 instances. That means almost 5000 rupees I'm paying it. So this strategy will work if it is a non-critical application and but you don't want to lose the customer. Like food store applications, or someone is buying clothing or something. If at all we are searching for a product and it is taking 4 seconds or 6 seconds, they don't like to stick to that and they will go and buy it from some other store, or food app also similar to that. So in that case, it's not that critical, but you can start with a lesser compute units and put it on an auto scale. So as and when the traffic is coming more, and without impacting that, maybe on a 50% of a memory or 60% of a memory, scale it up. So it automatically scales and you can cater the needs of them. Okay, that being said, let's come back. We have the basic plan. I have scaled it to manually scaled it to 2 instance. And here you can see that it reflects 2. That means there are 2 instances of that and there are 2 instances of this. So let's try this. And you can see that it is DW, it is 00F60. Now, what I will do is I will open an Edge browser. I will open an Edge browser and go to that. So when I go, it is, see that it is 0F60. That means it is one instance. Let's take instance 1, and that is instance 2. If I have 3 instances, the traffic will be distributed between all these 3 instances. That's what we are seeing. This is an computer and this is an instance. So how can you tell Swamy that this is running on 3 instances? That's a good point. We can probe it further. So let's go here and let me come back and go to web app scaling, and that's the bookstore, right? So this is the bookstore. It clearly shows that 2 instances are running, and we are seeing that also. One is F362, and what is the other one? Now, and one is F060, F362. Okay. The simplest way, the simplest way to find out is you can come to this process explorer. We'll do other probing also, but I'm showing you one of the simplest way to do it. Let's give it a minute. While that is bringing it, another, my favorite guy is this Kudu console. I don't know, for some reason I love this tool like anything. I see this in the process explorer for the bookstore basic. You're seeing 0F60B6. That's one of the instance, right? And another instance ID. The instance ID is F362EA. F362EA. So that means technically we are seeing that two instances are there. So let's do further probing. So when you come back here, so DW0S, that's a computer name on which it is running. That's the computer name. Okay, what is this? That's a basic. See that DWOS DW1IT. Ow. See that 001IT and instance is 0F 0F. Oh, that's in the same browser. I'm sorry. That is like 0F60. So that means on this computer, this is an instance ID. It's as simple as that, folks. On this computer, this is an instance ID. Let's switch back to Kudu console. Now, if I want to go to the another instance, F362. Okay, so this is F362 that is on this computer, 35Q. See, 0035Q, F362EA, F362. So that means what it is proved. When you scale up, Azure is taking care of routing the traffic to two instances. And literally we are seeing these two instances has been deployed in two different computers, right? That's what we have seen that in, and we probed this multiple ways. We went to the process explorer, we saw that, and we went to the Kudu console and we are seeing everything in front of our eyes that this is what it is, right? And another point to another point to focus or consider here is we can add this health check here. Right now the health check has not been enabled, but it is suggested to have the health check. So where is that? So this one. So what we will be ideally doing is, suppose if we are hitting, technically we'll be hitting the same database. I don't see um, two different instances. Maybe, I don't know. We might hit it if it is the database has been scaled. I'm not sure, but let's consider this layer. If at all we have API, two different instances of the API, and Azure is routing the traffic to instance 1 and instance 2. And what if the instance 2 is down? So we need to configure the health check. So that we will enable it here. At this point of time, it is disabled. Just wanted to show you that piece also. When you do this scaling piece and all this experiment, you have to focus on all these things. Like you need to do a performance testing, get the report, like how many requests are coming, how it is scaling up, how it is performing. Everything we have to take care take care of that when you do this before finalizing how many. See this, when we initially came that the memory was somewhere here. It didn't even show what it is. It was in cold mode. Now when we started pumping in the load, now it is almost it crossed 60%. It went to 62%. And also you can see that data in and out. These are very important tools. Okay. And the final tip for today is we can come in here and where we were doing the scale out. What we can do is go into the run history and we'll see in another one. No problem. At least I can come and show you in the activity log. Okay, I didn't that didn't scale up, but I can bump it up here. I think this is a good thing. We covered a lot. So let's come back and go to the step 3 of this process. Okay, so what we will do is we will come back to this one. Uh, so let's switch it back to that app service plan. And let's do this. Let's do from here. Let me go to this standard, and let me come to scale up, and we already bumped it to S1. That's a good thing. So let me close all these things, and we might need to deploy. We will have to waste 5 to 10 minutes time. I didn't get time to do that. I'm sorry for that. We'll do it live. Uh, and let me go to the API, the standard version, and let me go to, oh, instead of doing all these things, why don't we bump it up, because where I already deployed it. I think I didn't do any deployment here in this one. Just wanted to keep it for uh, scale out. Let's do experiments there itself. Deployment center, I didn't do that. Let's wait for 1 minute. Yeah, it makes sense. We will use the existing resources instead of going and deploying it. Let me see. That's the basic. I'll do one quick thing. I don't remember me deploying this last night. Okay, I didn't deploy. Okay, then it doesn't make sense to spend time on that one. Let's reuse this, the shared one. Whatever the shared thing which we have taken, let's start experimenting with that. If it doesn't work, then we'll create a new resource. That's cool. I'll come back to this and go ahead and let me bump it up to standard version. When we bump up to the standard version, the API which was working, now it will not work. I will show you. I want to create problems, then we'll learn from the issues, right? So let's do that. It's updating. Let me have a glass of water, folks. Okay. So, so here you have manual scaling as well as auto scaling. I'm sorry. And we see that run history didn't show when we were in basic or when we were in shared. It didn't do anything. Now it will show the activities. Let's see that in action. We still have a lot of time, and this is the JSON, and diagnostics and rest of the things are there. So the first thing first. Now we bumped up the shared to from shared tier to standard tier. So let's go back to the shared tier. This was working previously. It will not work. Ideally, technically, it should not work. If it is working well and good, it will not work. Come on. Ooh, I didn't bump up the IP address. So technically, what will happen is I have punched the hole in the firewall. What does that mean? Is I have unblocked the IP address. If I go to the show firewall setting, I have unblocked the IP address of this one. So looks like it is using the same IP address even though I bumped it up to different version. Last night I was facing that problem, but that's one tip, guys. If you bump up the TS, please ensure that if at all you are going based on the unblocking based on the IP address, if it is not the virtual network, you unblock only IP address. I didn't enable this. If I enable this, any Azure service can come and hit my database if they get the credentials. But I didn't enable this. I'm doing whitelisting case by case. I whitelisted my IP address and two of these APIs which we tested now, those IP address and the my development box in Azure through Azure Bastion. Only these four people in this world will be able to hit the database. None other than these four can hit this. Okay. That being said, let's come and see that how to do the auto scaling. So in doing the auto scaling, like manual scaling, we have seen that I can do all the way till 10 instances because this is a standard plan. All the way I can do from 1 to 10. We'll not touch that, guys, as we let me discard this if at all it is taking something into consideration. Okay, now let's switch to the auto scale. So in this auto scale, first of the option is let's scale based on the uh, specific reason. What we will do is we'll do this one, scale on a specific dates, scale on a specific dates. That means we will say that I need to have two instances on the specific date, that is GMT plus 5.5 during Calcutta time from 10 a.m. from 10 a.m. to I want to make it 9:58. Okay, okay, 9:58. So 9:58 till 10:10 or 10:10 or 20:20. I want two instances. So I'm not touching the existing scaling, whatever it is. I just want to keep it there. And I'm saying that scale to a specific instance. The instance count should be two. Time zone is India time zone. So what is the start date? From on 3rd February from 9:58 to 10:20. I want two instances to run. That might be some sale. We are giving some coupons and we are expecting a large number of people will come and they will go and purchase from our site. So that might so based on that we will have to scale it up, right? So that scale is already there. And sorry, my son is speaking to me. So uh, uh, okay, so that we did it. Now, if I come in here, if I see the run history, let's see that run history. Is it scaling up now? We can see here, not this. We'll have to go back to that shared API. That shared API, as well as we will go to the shared bookstore. Looks like it is still scaling up. Let's check the activity. Mhm. Because the scale up is rule. Oh God, it has to do fast. It had be kept a smaller window. Yeah, it will be done. It will not take more time. There you go. It updated the hosting plan. Oh, hosting plan it updated now. Then when it will bump. Okay, it still shows this one. I will say 4 instances from from 10:05. Yeah, 4 instances from 10:05. Okay, that's a default auto scale. You can see here default auto scale is 1 instances specific count, and this we are specifying that we need 4 instances from on that specific day from 10:05 to 10:20. Let's go to the next step. Let's create another scaling rule. We can add another scale condition. let's see. I mean, I want to wait and see that whether it is bumping. It will bump. I saw that yesterday. And let's see the scale out condition. Let's make it. It is 1 more minute. Let's make it 10:04. Let's see. And then we'll go to the next step and we'll go to the auto scaling. That's a pretty cool feature. I want to show that. Back to run history. Takes little time, but it will definitely do it. Maybe I'm doing some mistake. Let me check the activity log. Okay, cool. Never mind. We'll come back. We'll come back. I'll park it this one. There is a basic one. Let's work on that. I will go back to this basic one. First, let me bump this up to. Let me bump that also to S1 standard. The basic one also I bumped it up. And here we will do another one. Instead of that specific dates, we'll go by specific days. That means I will come in here. Let's check that it has bumped up to standard. Okay, it's already there. That was S2 because I already configured uh, this basic for 2 instances. I'm bringing back to 1. Let me go here. So we'll keep this under watch, the shared one. It still shows that, or we can use it this for we can use this for auto scaling. We'll keep it that. Never mind. So we just bumped it up. That's a basic one. Now let's come back to the auto scale condition. So we'll add it. That's a default scale condition. I don't want to touch that. So let's go to the specific dates. Based on the metrics we'll do, that's the third experiment, we'll do it. I'm saying that I want 3 instances repeat on specific days. So I want to do this on every Monday, every Wednesday. That is GMT plus 5.5. That's GMT plus 5.5. That will be from 10:05 to 10:20. Okay, I want that to be on the specific scale condition. Because what is happening is, even though it took the request and it updates to percolate it, it might be taking some time, but let's see that if this is working. We just said that on a specific instance count, I want 3 instance count on every Wednesdays from 10:05 to 10:20. And let's come in here. See that? Technically, I don't know what happened there. That's a different story, but let's see that. See, here it bumped it up to 3 instances. And if I come in here, this was the shared one. It still shows 1. I don't know why it's showing that, but never mind. We'll ignore that. So we have seen that when we added that specific instances, we said that the specific instances also we have 2 modes, specific start and end dates. So only for that one day and repeat on specific days. This is like a schedule. Every Wednesday you are giving a deal, 60% off. So you might expect, and you are giving it only for 15 minutes. So, within that 50 minutes, definitely people will jump into the site, try to buy a lot of things. Okay, that's pretty cool. We have seen that. Let's go back to confirm. Let me go to the resource groups and web app scaling. Here in the web app scaling and in an extra space, Which one did I bump? It's a basic one. I bumped it up. So if I go to API basic and I can go back to bookstore basic and I should see that. So here in the app service plan, in the app service plan, we are seeing S1 3 instances. That means 15,000 rupees plus a minimum. And here in API, it is 3 instances. And here it is 3 instances, right? So let me bring it back. Let me delete that condition. I don't touch it. So I deleted it. That's the only thing it is there. Now scale based on the metric. Okay. Scale based on metric. I want minimum 1, a maximum of 4, and default is 1. Okay, that's a default condition. I need to add a scale condition. So on metric. Uh, okay, I'm sorry. Discard this. I shouldn't touch that one. Okay. This one, I want to change it back to metric. I'm saying that minimum will be 2, and maximum is 5, default is 1, default is 2, and that is scale based on the metric. Uh, I'm sorry. I need to add a scale condition, and that scale condition is on metric. This is a scale condition on metric first. Let me save this. Okay, now let's come back. Add a scale condition. I need to add scale up first. Add a rule. Okay, so in this rule, what I'm telling is the average percentage of CPU. I'll go by memory because that's what it is bumping up there. Average memory percentage. It's somewhere around 50. Now it is less than 50. Now less than, now it is a value. Right now it is 53. I think there is no traffic coming in. Yeah, there's no traffic coming in. So what I will quote is, if at all, if it is greater than 55. Okay, so right now if you can see this, it is 53. The 55 is this line. So if at all, if it is 53 for a duration of 5 minutes, right, a shorter window I'm taking, increase the count by 1. I added that. Okay, and add one more rule. Actually, I should have deleted this. If an average memory percentage is less than 5 for 5 minutes, then decrease count by 1. So I have scale out and scale in, like expand and shrink. I have both those options. And I will go ahead and save this. Oh, actually, I messed up these two. It might fail, but we'll come back and we'll fix it. I should have removed this. That was my mistake. I'm sorry for that, but uh, it might not work. Just let it give us the control. Let's see. Okay, let me delete this entirely. Uh, that's a default condition. Let's add one more condition. Sorry for my just say. Okay, discard. I think it should work. Okay, we have the scale in and scale out conditions, guys. Chalo. So now what we will do is we'll come back here and we'll focus the what is the current percentage is 54, and this is basic. Okay, so we have load for basic. That's shared. We can pump in the load for basic. Let me close this. Let me close this. Let me check that if at all the IP address has changed and it is able to hit it or not. Because it went cold now. Maybe it would have moved from one infrastructure to other infrastructure. This when we bump up the app service, definitely it would have moved. Okay, good that we are able to hit it. Okay, so let me start pumping in this. It might take 10 minutes for us to see. I hope everyone will pray that it should work. I am running this. Let's come back over here and go to that. Okay, this guy has already started. Intelligent. We are pumping in the load, and let me pump in something else. I do another run of 10,000 runs. Technically, it should increase the number of requests from 2 to 4, 4 plus. That's cool. That's what we needed. And let me come back to, it was basic, isn't it? So I can come in here and undo the changes. So that means it will start pumping in the load to basic. That's what we need. I will close this, start a new instance. Let's keep a watch on that. And this, see that slowly it's bumping up. Now currently it is 56%. Oh, it's 58. That's cool. That's cool. So we need to see that the instance automatically spinning up. We'll see. We can collectively, let's pray. I'm bumping in more load. And let me pump in some more load from here. Start a new instance. And let me pump in this extra load. Okay, 6 requests, not enough. I will pump in some more extra load of 1 lakh. Let's let it hit. Still going around that. And one more of 1 lakh. Let me pump in one more of 1 lakh here. Okay, everyone, they are pumping in the traffic from all the places. And let's come and see that the request duration is going too much, and you see good activity here, and we can see this memory over here. Wow, that's cool. That's what we needed. It bumped it. So we have to wait for 5 minutes. In the meanwhile, we can go and check the activity log to see the app service plan change, as well as scaling up and scaling down, whatever we did it manually or through specific dates. Those will get reflected over here. Sometimes the logs will come after 15-20 minutes. That's not a big issue, but we can see that. And what else? That's what we're working on, basic, isn't it? Yep, you can see that scale down result and the scale up result, whatever we did it. And whatever the changes with auto scale up completed, and auto scale down completed. Like you can see this, all the things as are coming up and down. See, this auto scale and auto scale up and auto scale down was based on the specific dates or repeat specific dates. So we said that every Wednesday from 10:05 to 10:20, it was of that. And let's see the current bump. It should do. It will take some time, but I think I'm sure it should bump this. Let's wait. When is this? It crossed. It crossed around 10:15. We need to wait for 2 minutes, folks. There's a cooldown time also, isn't it? We will wait and we will see that. Let me check this. Okay, this one. Wow, the traffic is pretty much engaging. Almost around 5+ requests per second. That's too much of traffic. And let me come to this one and let me check that. Okay. Okay, here it shows only one. Maybe it's not updated properly. Yeah, the best way to check is we can get into the process explorer, see that how many instances this guy is running on. Okay, it has come back. See that? That was wrong. It didn't update. Okay, this is on one. Uh, if we come back, yep, now it is there. Let's see the time. What is this? 10:18. Now, if I consider from 10:15 to 10:18, it's 3 minutes. It's always 50 plus, 55 plus, whatever we put it in the scale condition is this one. The scale condition is the scale condition. Yeah, it is in here. It should start reflecting. Let's see that. Let's go to the run history to see. Okay, see that it shows the capacity has come down. It come down around what time? Okay, these were, as I was mentioning, these were the auto scale with that specific dates for that 15 minutes from 10:05 to 10:20. That's the 14 minutes gap or something. It was that. And JSON is the one which has got that matrix like this. We have this matrix condition and also based on the percentage like that is also configured. Let's see, come back over here. We have pretty much traffic and also we will be, yeah, the traffic, I mean the CPU is more, I mean the memory is more. Is more, it should start. So, I mean, it's taking a little bit time, but definitely it will auto scale because as when the metric is there, we already have the metric. Might we take some more time? That should be fine. So from 59, that was from 10:15. It's almost 8. It might bump it up in next 2 minutes or something. Let's wait for 2 minutes and then we can go on a Q&A while the traffic is coming in. Just to maintain the load, I will pump in one more lakh. I'm pumping in 1 more lakh of transactions. Okay, now it's crossing above. Last night I pumped in till 20 transactions per second. So today I didn't do that, but it is 50% of the traffic what I was sending in last night. But technically it will do it. Might be it's taking a little bit time. Never mind, uh, it will definitely pump it up. It's almost there. Let's see the condition. I think I still feel that something I messed up here. I shouldn't see this rule. But anyways, it will hit whatever the rule it is hitting. So if I go, if it is greater than 55 for 5 minutes with the cooldown time, and this is less than, oh yeah, technically it should come. Let's wait for 1 minute, and let me go here, try this. Is it bumping? Yeah, a lot of traffic coming in here also. You can see that data in and data out are too much of traffic there. And I think here also there is too much of traffic. Yeah, I mean, we are maintaining, but sometimes it takes a little bit time, but it will uh, definitely scale up because I uh, don't think that we can wait for some more time, but it will definitely do that. We saw that sometimes what happened is I would have done something wrong. If not, we have seen that on specific days, Wednesdays, it automatically bumped up from 1 instance to 3 instance, and it did brought it down auto scale. And now whatever we are pumping in also, okay, 5 minutes ago, looks like it is bringing in now. Right, see this? It is coming in little late, guys, but I think behind the scenes somewhere it is bumping up this operation. In the scene, it will bump. Definitely, it will bump it up for sure. Okay, let's come back over here. Come on. Let's. What is the current instance? Run history. Let's give it a minute and then we will go for a Q&A and keep this under watch. And if at all it bumps up, I'll reshare my screen. We have 4 minutes time. We can go on some Q&A. Okay. Now, what is next after all these things? The next we will be playing around different applications. How do we deploy all the latest stack like Angular 13, React 17x, and Node.js, .NET 6 Web API, .NET 6 Blazor WASM, .NET 6 Razor. So this, whatever we were seeing is .NET 6 Blazor WASM. Sorry, Razor. This is the .NET 6 Razor pages. This one. Okay, so we'll see what it takes us to deploy all the latest stack into Azure. Okay, I think that's the one which is taking a little bit time, but we are sure that it will bump it up. It will not do. It's my mistake when I was configuring. I didn't configure properly. Cool then, no problem. Let me switch back to the Q&A piece. And okay, uh, okay. Uh, any queries, folks? Any queries? And any suggestions on the session? Was that good? Was it okay? Or was it bad? Like positive or negative feedback? So that will help me to fine tune my content and other things. Hello, anyone? Rohit, Milan, Ashwin, Kuljit. Thanks, Sarna. I don't know whether I'm pronouncing your name properly or not. Rohit, Sagar, Kuljit. Thanks, Kuljit. So, any suggestions, please feel free. Or if you have any queries, please feel free. We can discuss that. So, hope to see you guys in the next session where we'll be playing around with multiple application stack. With multiple application stack. Is there a way that the font size could be increased? So actually, I should have uh, increased it. The portal zoom size, Kuljit. I will see that in the next session. I will see because I saw the message which you put it at 9:41. I just saw now around 10:30. You know, so I'll see. I'll ask that. Uh, uh, okay, thanks, Kuljit. Anyone else has got any queries? Avinash, Bhubesh, Sabapati, Milan, Rohit, Sagar, Sarana, Sham, Srireka. I don't know. Am I pronouncing your first name or last name? Moni and Prajapati. Anyone has got any queries or any suggestions? Did you like the session? Was that okay, good, bad, or ugly, or positive feedback or negative feedback? Please feel free to give so that I will that will help me to fine tune my future sessions or the content. Okay, so please join me next week for deploying of all this entire latest shiny trendy things, uh, Blazor WASM, web app, Razor, all .NET 6 and Angular 13 app and React 17 and Node.js. The mean stack or the MERN stack, I don't know what stack it is, but okay. Thank you guys. So, Rashmita?
Thanks. Thank you so much, Swami, and thank you all for joining us today. Please feel free to share your feedback about today's session. Also, please use the Learn module link, which is I've already shared in the chat and also displayed on the screen. This will give you access to additional resources to take your learning further. Please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again and enjoy the rest of your day.
Stay safe, folks.